And the main reason for that is a number of problems that we have caused by interventions in the system. One of them is coastal squeeze. I don't know if you can see it, but you see here this little rectangle sticking out into the sea. That's a resort. That's a resort that was allowed to build there and very close to the shore. And it's not only the resort that has caused the erosion there. Let me be clear about this. It's multiple choices. Multiple causes. Another cause is that you see this piece of land over here. Maybe you also see the bit over there. Those two are land reclamations in the estuary. And I don't think it'll be a big surprise to you, but where do you think they got the sediment from? They got it from the local system. So they took about 1 to 2 million cubic meter away from the sediment in the dynamic system. That's another cause of erosion. Then we have, as you see maybe, sorry, I have to bring the cursor in. You see over here, there's a delta, an underwater delta. That is sediment that is flushed out in the rainy season from this estuary. And that used to be the traditional bypass system. Sediment would be brought along this coast to this region over here. And then after the floods had cleared the entrance, the sediment would deposit here. In the dry season, it built up. And then in the rainy season, it would be flushed again. And that would then be deposited in the end to the downdrift coast. So that was a cyclic system. But we've built so many dams now in this catchment of this river that the sediment load has probably gone down dramatically, which means that where originally the river was helping to build this delta, it was now all the updrift coast that needs to do that. And so this has caused really serious problems that are ongoing now. And there is action, but it's not the right action. Here at the bottom you see they try to build revetments, and you can already see that the revetment is failing because they need to put bags in front of it. A hard revet like this in the end will only increase the erosion. It will also work as a stopper of longshore transport. And here you see the application of geotextile bag sediment, which on energetic coast is usually failing, because the problem when you have an energetic system with waves, there will be erosion here at the toe, and the integrity of the structure will be lost. So we're trying to talk to Hoi An authorities to find a better solution. Okay, let's go to other fringing habitats. Salt marshes and mangrove are habitats that are spread all over the world. And so I've probably made clear to you that these habitats need space to, as Doody calls it, operate. And so what does it mean, operate? Operate means you have to be able to absorb extreme events. After an extreme event, there will be damage in your habitat, and it needs to rejuvenate. Another fact is that we need sometimes space to absorb relative sea level rise. Because if we don't add sediment to the system with relative sea level rise, the coast will retreat. So the habitat needs quite some space. And in the case of strong relative sea level rise, I'll explain that to you in a moment, we maybe even need to set back our coastal system to give it space. Let me first show to you the distribution of mangrove and salt marshes, because they are really counterpart. You find mangroves where it doesn't get too cold in the coldest months, because they need warmth. And other than that, you would have salt marshes, unless it gets too cold, the blue lines. And there you find salt marshes. And they have a lot in common in their behavior. We'll now concentrate on the mangrove in the Mekong Delta, and let me see if we can indicate it. It's somewhere over here. So here you see the mangrove in the Mekong. Here you see the river coming all the way from China, and it goes through 6 countries, and it ends up here in the Mekong Delta. So here's the Mekong Delta. Sorry, here's the Mekong Delta in the right picture. And well, here you see the scale is something like 60 kilometers. So say this is something like 300 kilometers by 300. It's approximately the size of the Netherlands. There's quite some inhabitants. There's nearly 20 million people living there. So it's quite, there's quite a lot of people making a living there. The biggest city is Kanto, over here. This is about 1 million. And concentrate on the mangrove. Where do we find mangrove? There where you have salt water and the transition between salt and fresh. And what you see is the green spots are indicating the mangrove at one stage of their existence. I'd say if you would draw a map for nowadays, it would be less than this. This is a couple of years ago, maybe 10 years ago. And what you see is these numbers over here. That is areas we have studied, and I'll show you some results of it. And the colors indicate the erosion and or accretion or stability. And the warm colors are erosion. And the colder colors are stable or sedimentation. And let us now first concentrate on the areas near the river mouth, because there we assumed that there's still sediment available to keep a healthy mangrove fringing habitat. And then let me move on to this area over here, Kamal, where you will find very strong erosion at this moment. Sorry. You find strong erosion at this moment over here. And that has 2 other reasons which I will explain to you later. Let's first go to the areas here, which are near the river mouth. And we assume that there's enough sediment available, if they're not squeezed, to survive. Here's Sok Trong, that's about here. It's about here, this area here. And what you see there is, I think the Google Earth picture. What you see here is that the original dike system was running over here. And this area over here, all this area was healthy mangrove. And what they've done in the last 5 years, they relocated the sea dike very close to the shore and developed this whole area into aquaculture. And what you can see is that there's hardly any healthy mangrove left. And my prediction is that this will be here. And here an in the field example of the result. Sometimes it's not that the primary dike is replaced, but sometimes the wish to have more aquaculture would result in a secondary dike, not able maybe to withstand very high waves, but creating a zone where they take away the mangrove and start aquaculture. And that, of course, if you get into trouble. Compare this here, situation 2006 on top, where the fish farm with its secondary dike in 2006 was over here. You see already this farmer who went even a little bit further is already experiencing mangrove loss over here, right? And then since 2006, these farmers have extended their fish farms. And you can see again, if it gets too narrow, there's no space for the habitat to operate. And you start losing habitat. So we've checked this numerically and testing our hypothesis, that is, if the primary or secondary dike is too close to the foreshore, you can expect erosion, and the health of the mangrove is under stress. And so here we've simply based this on a Google analysis, Google Earth analysis, where each of these points are a certain section, where the error bars represent the variation due to characterizing a stretch of coast just by one value. And note that it is accretion, and below this it is erosion. Okay, here you see the width of the mangrove, and what you do see is that if the mangrove width is under something in the order of 200 to 300 years, you have a serious chance of losing your habitat. When it's larger than that, it looks like your habitat is able to. Remember, this is for locations where the sediment source is not restricted. Okay, so this is a perfect example of mangrove squeeze. We've also done some research on it, what we think is important. I can skip this, Abraham, because otherwise I may talk too long, but so I won't go into, say, more research stuff, but it all has to do how well can mangrove dampen wave action. I want to end with something which I think is of super importance for every area that has mangrove, because we've now talked about the squeeze from the land side, say the land-borne squeeze, but this area over here, is the Ca-Mau province, and since 5-6 years it is experiencing disastrous erosion of nearly 20 meters per year. And there are suggestions by some of my Vietnamese colleagues that say, well, it's wave action. I don't believe that for one bit, because the waves are no different the last 5 to 6 years, maybe slightly different. The wave-driven gradients cannot cause this. What is the case here is that besides squeeze, because there has been a lot of squeeze as well, there is another very serious problem. And that is there's no match between the source, and the source of sediment are the rivers. That sediment is made available for the coast and the foreshore and the mangrove areas. And in the old days, it would reach as far as the Kamau province. However, the source is one aspect that I want to discuss with you, and then we go to the sink. Let's first go to the source. If you look at this graph, you see that the estimates up until, say, the 90s of the last century are something around 150 megaton per year. But more recent estimates are that it's down to 1/3 of its value from the 90s. Also notice, interestingly, if you simply take a Holocene estimate by calculating the amount of sediment that is in the delta since the Holocene, you get around that generally accepted estimate value. But you notice that nowadays the source of sediment has decreased with 2/3, with 66%. So there's less sediment available to fill the sink. And the sink is the accommodation space that is created by relative sea level rise. Now, that accommodation space is, to explain to you maybe, that accommodation space is not only the mangrove area, but it's also in front of the mangrove area, the shallow foreshore. There, sediment is needed from the source to, for instance, to compensate for sea level rise. Geologists call this accommodation space. So as sea level rises, then the system will want to fill that accommodation space with sediments. Now imagine that in the old days, without any development along the coast, this region was only dealing with a relative sea level rise of 3 millimeters per year. I don't know if you can see it in my finger, but my finger's here. Sorry, it should be here. Only 3 millimeters, right? But look at this picture. If you drive through the Mekong Delta, you will see at nearly every bridge or every culvert, you will see this type of transition between the road and the bridge. What you see is that between the bridge and the road, you will often see a transition of a steeper road than away from it. That is because of differential subsidence. What happens is a bridge is usually founded on piles, has a foundation on piles, and will not sink as easily. The road, however, has no foundation. It means that this road has subsided. Now, I don't know what your estimate will be of what you see here, the subsidence has been, but my estimate is between 10 and 20 centimeters. And I've been driving through that whole delta, and I tell you, you'll see this everywhere. And you see everywhere about 10 to 20 centimeters. Now, we have learned that these roads were all created in the last 10 to 20 years. So it must mean that the subsidence is now 1 to 2 centimeters per year. Now compare that to 3 millimeters per year. That is, say, 5 times as much. That means that the sink for the sediment has increased with a factor of 5. The source has decreased with a factor of 3. So we lack enough sediment to compensate. And that means that, here's the summary of it. So the sediment source has reduced substantially, and the accommodation space has increased from a few millimeters per year to 1 to 2 centimeters per year. And so basically what's happening is that, that when you have areas like Kamau over here, which are relatively far away from the source, they have no chance. They cannot catch enough sediment to stay alive. And it creates an enormous erosion. And that is, of course, increased by the fact that squeeze from the landward side does not allow the system to move inland, which is one of the solutions, you could say, is to have managed retreat, but of course that often is not very much wanted. So we need young people like you to come up with solutions. One of the solutions could be that where for beach and dunes we can use sediment nourishment as a solution, I think we can do this here as well. But it's really an order of magnitude more different, because we need not only the quartz and the silts, but we also need nutrients. So nourishing a mangrove system is not that easy. And some of you may think, well, replant them. That happens a lot. There's a lot of replantation, but if you look in the literature, you see that most of the replantation is doomed to fail because the sediment isn't there. And so I would encourage people to really research this issue and come up with solutions. So that brings me to the end of my story. We need to be very careful in squeezing our land-water transitions. By the way, also our water-water transitions. Think, for instance, of hydropower or irrigation dams. That's also squeezing water-water transitions. And so I think this is a very important issue, especially in deltaic areas. Thank you for listening, and I'll now ask Abram to maybe lead us through some of the questions.
Yes, thank you very much, Marcel. We will now begin with the question-answer session. People have started typing in their questions, and we have some questions from before that we received through our website.
Yeah.
So what I'll do is I'll create like a notepad sort of a thing and paste those questions there, so people and the speakers can see what question is being addressed at the given point of time.
Okay.
So please give me half a minute
Yeah.
to sort of do that. Almost there. Yes, there you go. I think this is big enough.
Yeah, yeah.
The first question is from Ahmed El Wazri. And he says, I'm just going to read it out.
Yeah, yeah.
I was wondering about professor's opinion concerning the Nile Delta. Do you think the necessary measures are taken place to defend its inundation? Also, I was wondering if you have heard about Heracleonthonis city that was discovered off the shores of Alexandria under the seawater, where the major theory behind the city's collapse is the sandy nature of the soil that drove the city down under the increased population and economic activities, and being located on the meeting points between the Nile and the Mediterranean Sea. What are the chances of that happening again to some of the present-day cities of Rashid and Damietta, which are located at the same meeting points between two Nile branches and the Mediterranean Sea? Is or was there cases like Heracleonthonis in other places in the world?
Yeah, that's a lot of questions and ideas behind it. Thank you for that question. Let me say that, yes, there are more cases. Actually, we have one very famous case in the Netherlands, not as famous as your case, but the Romans have built a castle close to the shore in the center of the Netherlands. And that has disappeared, and it appeared again after erosion. So yes, we have that as well. It is, I think, it's not often just one cause that is happening in a deltaic system. There can be so many causes for its failure. It's usually Usually it is a combination of causes, like in the Mekong, for instance. But you have we've had the very same in the Delta of New Orleans. Let me take New Orleans as an example. In New Orleans, there has been a lot of resource extraction from the ground. That has led to stronger subsidence than due to sea level rise alone. And the Mississippi River has been dammed more and more to promote navigation, so that all the sediments that the river used to bring do not stay near the coast, but are simply blown into the big depth of the Gulf. And well, you all know the story of Katrina. It's basically the disappearance of the intertidal areas and wetlands that have weakened the defense of that delta. And I don't know a lot of detail about the Nile Delta, but men have been active in the Nile Delta for a long time, and the Nile River has been managed largely for the good of Egyptian agriculture, but of course the sediment load of the Nile will have decreased substantially, and so it stopped at one time to be its source of sediment. And then, like in our country also, subsidence is not only due to groundwater extraction, and that is one thing you may be able to stop, but simply drainage will also make you subside. And so I'm struggling a little bit with your second question. Do you think the necessary measures are taken place to defend its inundation? I wouldn't be able to answer that, say so strongly, because it's also partly natural. When we have sea level rise, we also have natural subsidence due to compaction of material. It's just that in our present times, we need to accept that for many deltas on this world, nearly every delta, we have to accept that it's not anymore logical that the source of sediment is untouched. There's so many dams in the big rivers that have been built that we will start having to live with the idea that deltas will retreat rather than extend. And we've been spoiled that for such a long time they have extended. But in our day and age, we have to accept that that is not anymore the case. So then when you say, do we take the right measures? I think that totally depends on what objectives you want to have. If the ecosystem is very important, I would say protect your ecosystem, but accept it's also dynamic, and so you may strategically have to retreat. But if you make a different choice, which is also understandable, then you may have to decide to find solutions, new solutions to this problem. That's what I can answer you. Are we moving on to the following one?
Shall we move on to the next question? Yeah, it is from Prem, who says, do sustainable development frameworks recognize delta issues separately? Is this recognition formalized through some conventions? May I ask Renske to answer that question? And
wait, now I'll turn it.
Okay.
Oh.
Well, thank you for the question. Well, when we are thinking about sustainable frameworks, we are also thinking about the new Sustainable Development Goals. And I think that you see there is more and more attention also for water and water systems, but there is not a recognizing of the delta level as a specific level. And I think because of the concentration of problems, we from the Delta Alliance, we try to get more attention, also to get more attention for monitoring the Delta issue. Because when you are monitoring on the country level, of course, you get all kinds of progress or degrees, but more the specific attention for deltas. And so I would like also to ask the other participants what they think about it. But from the side of the Delta Alliance, we try now, also with the Sustainable Delta and other institutes, to get more attention also for the formalized, recognizable Delta issue. So we hope we get more formalized attention for it, also for the future monitoring. Thank you.
Thank you, Renske. To that, I would also like to add that this is a series of 3 webinars. So this is a process. And I would encourage you, all the participants, to look at this as a series of webinars and look at this as a phase of engagement with the Delta Alliance and also with the international Delta community as well, some of which might lie outside the scope of Delta Alliance as well, and help the international Delta community grow. And the Delta Alliance itself would be would make for an extremely useful platform towards that objective. The next question, I think this can be put to Marcel, is from Dong Dong Shao, who says, are the mechanisms of losing mangrove habitat and salt marsh due to coastal squeeze the same?
This is from one of our Delta wings. Thank you very much for your question. I think the mechanisms are the same. You're probably familiar with the Jiangsu coast, Jiangsu province, say north of the Yangtze estuary. And what we see there is that the Yellow River once ended on the northern part of that coastal cell, and it delivered loads of sediments to the system, and the sediment moved along that coast in southern direction. And for instance, it formed the famous radial sandbanks just north of the estuary of the Yangtze. And but what we do see now is that where the Yellow River ended at one stage and brought a lot of sediment, that sediment has now all been transported to the south, and we see no erosion there. So basically, we have a similar mechanism that is taking place there. I think that should be an answer.
The next question is from S.V. Vijay Kumar, who asks, are the erosion processes along a river front that are getting urbanized as along seafront photos that are shown? I guess what Vijay Kumar means to ask is, are the two processes similar, urbanization along riverfronts and seafronts? If not, what are some of the key differences? I'm paraphrasing.
Well, it's not totally comparable. The erosion processes along a river are, unless the river is very squeezed, but are not as strong as along a coast. A coast needs more space to operate, as Dudi calls it. But you're right. I mean, the transition of our rivers and land use has led to rivers that are not having, say, a broader land-water transition than for an ecosystem would be nice. Of course, the indictment of rivers, because we're talking about, say, rivers in in the downstream side of the catchment area. The rivers have been endiked to prevent flooding and also to increase navigation. But yes, you are right that we need to sometimes worry about it. That's why in the Netherlands we've had so-called this Room for the River project. That, by the way, we sold that as a solution for flooding, but a very important objective was also to restore that land-water transition and make it more natural for the ecosystem.
The next question is from Dan P. And I would like to get thoughts from both Renske and Marcel on this, which is deltas are known to be fertile lands due to upstream activities. What is your opinion in converting parts of these deltas for agriculture so as to attain food security? And there's a second question which is about deposition of sediments has caused creation of large accreted lands like in the Kenyan coast. What is the best use of such lands bearing in mind their morphological formation? I guess these are two separate questions and can be dealt with one after the other. So maybe the first one.
Well, what I think is that basically it's the same question, okay. Because I don't know what DMP means, but deltas are known to be fertile lands, not so much due to upstream activities, but due to the fact that the river floods, and then when it floods, it brings in the sediments that make the deltas fertile. So that is the reason why there's a lot of good agriculture in deltas, because they are very fertile. And basically, agriculture is one of the most important activities in many deltas, although the urbanization gets stronger and stronger. So sometimes there is a tension between urbanization and agriculture. And yeah, the deposition of sediments has caused creation of large accreted lands. And so what is the best use of it? Well, the best use of it is to build scenarios for both urbanization and other activities that are sustainable and that contribute to your view on how the country should develop. And then what's important is that we prevent mistakes. Prevent mistakes like cutting out source of sediments. And if we do that, then we have to respond to prevent additional subsidence than due to relative sea level rise alone. And so maybe Renske, you want to?
Yeah, I want to emphasize that it is important to look ahead on the long term. What kind of opportunities, what kind of possibilities are you foreseen in your country? And then you have to look into the current situation. What kind of steps can we make? And that's important to have not only the physical situation, but the social situation, the economic. And that's so important to have a kind of integral approach for these areas. And that's not only, well, what I want to say is that's also connected is what kind of governance do you need to make these steps? So it is always a very complex situation in deltas because they are valuable and they are vulnerable. So you want everything to keep it like this in the biodiversity and so on, but you want also to develop, and that's the challenge, I think. And we have to learn from lessons from other countries and deltas, but we are also looking for a kind of adaptive delta management, how to make these steps, looking forward and acting now, because we can't wait. And there are always a lot of uncertainties, but you have to act. And I think that's one of the questions we have to answer and to develop together with other wings and other knowledge and policymakers together to find out in what way we can going forward in this very challenging situations.
I think actually, Aram, that answers also the question below it. That's a question about the governance structure. I don't know these niger deltas very well, but from this question I get really the idea that there is happening what I'm afraid is happening in many fastly developing deltas, that the governance structure is not strong enough to prevent that initial development that is indeed squeezing the resources of the deltas beyond all expectation. I think the solution there is indeed that you need to convince the government and all those ministries that have a say in the development issue, that they get together and make a long-term planning and regulation, and of course enforcement, for the development of the coastal zone. And then simply look at other countries and learn your lessons from the mistakes made there. And I know this is easy to say, it's not easy to do.
Thank you so much, Marcel. Before we get to the next question, I'll try to find a more sustainable solution to the camera angle problem than this one, which threatens to Okay. Okay. We now go back to excuse me, some of the questions that we received by email. One of them is well, I guess this is also related to the question we just answered, the question we just addressed.
Yeah.
Governance measures are very important along with technical solutions, especially because the issue of squeeze is one of development. And development also means vested interests like real estate developers and sand miners. Do you agree? And to what extent are technical solutions informed by realities of the governance? So when you're in the lab, for example, or when you're looking at data and when you are like visualizing technical solutions, is that process also informed by real, like, the more governance or sociological aspects of it all?
Well, sometimes it is separated because you are so concentrated on your technical measures. But when you are working in a Delta country, like we are now doing in Myanmar or in Vietnam, you see from the first step you are working, you have to deal with the governance situation. Because when you are talking about water management, in some countries, in 5 ministries, they all have some aspects in their responsibility for water. And then we are not talking about irrigation or agriculture. They're all separately. And when you are looking to this kind of solutions, you need them all. So you have, from the first step when you're working in a country underground, you feel the governance questions. So well, we are more and more also including in studies, and when we are looking to PhD research, governance is one of the very important aspects. So it is of course not a separate question, but you have also to connect it with your problem, with your concentrate your research, but you can't without, because otherwise you have a nice solution but no implementation.
Mm-hmm. The next question is by Viet. This is also a question we received by email. I'll make it bigger so everyone can see it. How high-tech are the technologies for managing the coastal squeeze? For example, the sand engine. And how expensive are they? Is it something we can expect developing countries to implement once they acquire the know-how? Or are they realistically possible only for implementation by the rich countries?
Yeah, well, this is a very interesting question, and it is again, there's not just one answer, right? You see a tendency that for those countries that can put their hands uh, on sediments, sand, against a reasonable price, that they more and more choose that as an alternative for hard structures. But I emphasize the first part of my answer, that is that sand needs to be available not too far away, because the price of bringing a cubic meter of sand to a coastal system depends on the distance over which you have to transport it. And so you see that in those countries where sand is available at reasonable distances, like below 100 kilometers, that on the long term, it is cheaper to use nourishment as an alternative for or to manage coastal squeeze. If you compare the hard structures with bringing in the sediment, then people have the wrong impression that the hard structure will solve problems forever. The experience is it does not. So what is usually done is that when in some countries where they make a comparison, they only think of the initial investment for the hard structure and no maintenance. But they know for nourishment you have an initial investment and maintenance. But the experience is that hard structures get very expensive in terms of maintenance in the end. So if you have the sediment available at not too large distances, my proposition is it's cheaper to use sediment. So whether you're rich or poor, it is just a better solution. And yeah, it's also a matter of know-how. In many countries, people are only used to think of hard structures as a solution because they've never seen anything else. But there's a lot of knowledge now, and also developing countries can implement this.
Thank you so much, Marcel. I think we have overshot our scheduled duration by about 15 minutes now. So we should now stop. But I can see already that a lot of people are still typing in their questions. So if you have any further questions for the speakers, for myself or for Renske, then you can send them to this email ID, which I'm typing in the chat box right now. It is info@thewaterchannel.tv. If you have any further questions, please send them to this email ID, and we will definitely get answers for you from Renske and from Marcel. With that, I would like to say thank you very much for participating. I would like to thank the speakers for their presentations. I would like to thank the audience for their patient engagement and for their very interesting questions, which continue to come in.
Yeah, I see, for instance, that last question, you will send it to me, and then I will put it through the right people to give the right answer. Because I wouldn't know how to answer it now.
Okay, sure, that too.
And don't stop with your questions,
Yeah,
because
right.
we like to stimulate this kind of discussions also after today.
Yes, absolutely. This is sort of the point of the series of webinars, which is being co-organized by TU Delta Alliance and the Water Channel. Again, I say this is a series of 3 or 4 webinars, which will take place between now and the end of this year. I would like to draw your attention to the website from which you entered this webinar interface, which is thewaterchannel.tv/webinar. I'll also type it in the chat box right now. Let's see how fast I can do that there. On this webpage will be shortly available by some point tomorrow, a recording of today's session, highlights of today's session, and also in the days to come, the announcements about the future webinars. Thanks again. Please be in touch and see you at the next webinar. Thank you.
Bye.
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 Bye.